Hi, this is Sohail. Today we will provide a brief introduction to EdrawMax software, which is a powerful tool for drawing process schematic and thermodynamic cycles. Additionally, it can be used for creating building plans, presentations, and various charts, including Gantt charts. For this session, we will focus on thermodynamic cycles. Let's start. The environment of the EdrawMax software is incredibly user-friendly, resembling Microsoft Office software and making it easy to draw schematics. The basis of drawing in this software is drag and drop. You can simply drag components onto the main sheet and connect them to create a thermodynamic cycle or process schematic. On the left side, we have the library offering different categories depending on our cycle and project needs. For instance, there are industrial items, electrical components, and thermochemical elements for the plants. Each category contains various components. If we require additional components, we can search and download them from the web, remove their backgrounds, and import them into the software library. In the top bar, we have tools for graphical changes. Firstly, we can adjust text setting such as font, size, and color. There is also a connector tool for linking components, a shape drawing tool, a typical file function like saving and exporting the projects, and also the insert section allows us to add tables, pictures, charts, and apply effects to the text and formulas for our schematic and plans. Moving to the right bar, we have options to customize components, adjust line, thickness, and color, and apply effects using desired templates. Let's proceed by drawing a simple cycle and discussing the library, formatting, and the tools available in the top bar. In the library section, we can search for components that we need, and the software will scan through all available components, then recommend some based on our search. For instance, if we will search for a turbine, we will see available turbine components that we can drag and drop onto the main sheet. To start drawing our schematic, we can select one of them and then go to the next component. If we need another component, we can import it from the website or our computer and then drag and drop into the main sheet. There are various categories, and for all thermodynamic cycles, there are different components in EdrawMax that can be utilized to create comprehensive schematics for our paper or projects. Additionally, we have the option to create either 3D or 2D schematics depending on our preference. For instance, we can find both 2D and 3D turbines in the software as you can see. Moreover, there is an option to combine 2 or 3 components to create a new one, allowing for greater creativity and innovation in our schematic or plans. Thus, it is straightforward to create a basic schematic or flowchart, but the depth and the complexity of the flowchart depending on our goals and creativity, which can be enhanced using the software's tools. To be familiar with the concept of this software, we can draw a simple Rankine cycle and connect all components, creating a Rankine cycle schematic. We will then adjust the thickness of the connectors and the color of the components, applying changes to our project, and afterward we will save our project in different formats to explore the software's capabilities for creating flowcharts. Basic Rankine cycle, we will need a turbine, which can easily drag and drop onto the main sheet. Similarly, we will search for a condenser, choosing from various options depending on our preference and goals. If needed, we can import other components. Alternatively, we can explore heat exchangers as an alternative to condenser. Once selected, we also add a pump and also a boiler, customizing each component size and color. Like other software such as Microsoft Word, we can zoom in and out of our main sheet and adjust the size of each component, and also we can change component colors and personalize them further using options in the right sidebar. This includes modifying light thickness and applying uniform formats across all components like this. And also, we can delete the part of each component by clicking on that and press the delete button on our keyboard. After placing our components, we will connect them using the connector tool in the top bar. By clicking and dragging, we will link the turbine's outlet to the condenser inlet, adjusting connectors and their thickness as needed. We will continue connecting components, ensuring the flow matches the cycle's characteristics. Once completed, we will have a simple Rankine cycle consisting of a steam turbine, condenser, pump, and boiler. Additionally, we can add text boxes to label components, adjusting font styles and size as described. And also we can copy text boxes to the streamline labeling. Once satisfied with our schematic, we will save it. Before saving, we will select the components we wish to include in the file. We will then navigate to the File menu and choose the desired format for saving, such as EDDX, PDF, or JPG. For example, for the JPG one, we have to adjust the resolution and then we have to save the project. After saving, we will have a high quality diagram of our cycle. This was a brief introduction to the software. As I mentioned before, it is a very powerful software and we can create very complex schematic with this software. It's up to our creativity and innovation in using the software tools. Thanks for your attention.